Ever wondered what happens when we heat ice cubes in a pot on a stove? An intriguing question, isn't it? It's like a sneak peek into the fascinating world of science, where we delve into the concept of states of matter. It's an integral part of our daily life, playing a vital role in everything around us. Now, let's embark on this scientific journey together to unravel the mystery. By the end of this video, you will know the answer to that question and much more about the states of matter. You might already know that matter exists in three primary states: solid, liquid, and gas. Let's delve a little deeper into each of these states and discover what sets them apart. First up, we have solids. Think of a rock or an ice cube. These are examples of solids. Solids have a definite shape and volume. The particles in a solid are closely packed together and are arranged in a fixed pattern. They vibrate in place but don't move around much. This is why a rock or an ice cube maintains its shape. Next, let's talk about liquids. Imagine water flowing from a tap or milk poured into a glass. Liquids, unlike solids, don't have a definite shape, but they do have a definite volume. The particles in a liquid are less closely packed than in a solid and can move around a bit more freely. This is why water takes the shape of the container it's poured into. Finally, we arrive at gases. Picture the air around us or the steam rising from a hot cup of tea. Gases have neither a definite shape nor a definite volume. The particles in a gas are far apart and can move around freely. This is why a gas, like the air we breathe, can fill any space it's given. Now, these states of matter aren't stagnant. They can transition from one state to another. For instance, if we heat an ice cube, a solid, it turns into water, a liquid. If we continue to heat the water, it turns into steam, a gas. These transitions are known as melting and evaporation. Similarly, if we cool the steam, it condenses into water. If we freeze the water, it turns back into ice. These transitions are known as condensation and freezing. So these are the three primary states of matter and how they transition from one to another. But what causes these transitions? Remember the question we asked at the beginning about heating ice cubes? Let's dive into that now. It's all about heat and how it changes the states of matter. When we heat ice cubes, we're adding energy to them. This energy causes the water molecules in the ice to vibrate faster. As the vibrations speed up, the ice begins to melt. This is when we witness the first transition, from a solid state to a liquid state. The ice, a solid, turns into water, a liquid. Fascinating, isn't it? But the transformation doesn't stop there. If we continue to heat the water, the molecules will vibrate even faster. Eventually they'll move so fast that they'll break free from the bonds holding them together. This is when the water starts to boil and turns into steam, a gas. This is the second transition, from a liquid state to a gas state. In both transformations, heat plays the star role. It's the energy that drives the transition from one state to another. Without heat, the ice would remain as a solid and the water would stay as a liquid. So what's the takeaway? Heat is more than just warmth. It's a powerful force that can transform the very state of matter. And the humble ice cube, it's a perfect demonstration of this incredible process. And that's how heat changes the state of matter. Now, it's time to recap what we've learned and have some fun with trivia. We've journeyed through the fascinating world of matter, exploring its different states: solid, liquid, and gas. We've seen how a humble ice cube can transform from a solid to a liquid and even a gas, all with the magic of heat. Ice, water, steam, it's all the same matter, just in different states. Let's put our thinking caps on for a moment. Can you think of other examples where heat changes the state of matter? Perhaps melting chocolate or boiling an egg? And here's a fun fact. Did you know that glass is actually a supercooled liquid? It might look and feel solid, but on a molecular level, it's still flowing, albeit extremely slowly. Isn't science fascinating? Remember, the world around you is full of wonders waiting to be discovered. Keep exploring.